Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the lines. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. So here we are required to evaluate the orthographic projections of an oblique line when both the ends of the line they happen to lie in the first quadrant. So we have been provided with the coordinate locations corresponding to the two endpoints of the line A, B, two endpoints of the line AB over here. So while the end point A of the line, it is lying 25 millimeter from the horizontal plane and 10 millimeter from the vertical plane, and B of the line, it is at a distance of 50 millimeter from the horizontal plane and 45 millimeter from the vertical plane, and the distance between the end projectors of A and B points measured parallel to the XY line, it happens to be 60 millimeter. So with this information, we are required to draw the front view, top view and the right hand side view projections of the line, assuming that the line is lying in the first quadrant. We are going to start with the construction of the orthographic projections of an oblique line. So here the front view we are going to draw over here onto the vertical plane. The top view projections of the line AB will be obtained below the XY reference line, and the right hand side view projections of the line will be drawn on the left hand side of the front view projections over here. So let us proceed with the construction of the orthographic projections of the line AB. So here we have drawn the XY reference line, which is the intersection of the horizontal plane and the vertical plane. Here we have got the X1 Y1 reference line, which is the intersection of the profile plane and the horizontal and vertical planes over there, and this is the transfer line which we have drawn in this particular case at an angle of 45 degree with respect to the XY reference line, such that whatever distances of the points will be there with respect to the vertical plane, so those distances from the top view, they will be transferred onto the profile plane using this particular transfer line. So here we have been provided with the coordinate locations of the point A, assuming that point A, it is located in quadrant number 1. So if the point A is located in quadrant 1, so the distance of point A above the horizontal plane will be 25 millimeter, and distance of point A from the vertical plane will be 10 millimeter in front of the vertical plane. So the front view projections, that is A dash, will be drawn 25 millimeter above the XY reference line, and wherever we draw the construction of front view projection corresponding to the point A, that is A dash, onto the same vertical projector line below the XY reference line, depending upon the distance of the point A in front of the vertical plane. So this happens to be 10 millimeter. So 10 millimeter below the XY reference line, we are going to obtain the location of the top view projection corresponding to the point A over here. Now we have located the front view and top view projections corresponding to the point A. And another thing which is available with us, that is the distance between the end projectors of the ends A and B measured parallel to the XY line happen to be 60 millimeter. So this is the vertical projector line drawn through the point A, which contains the projections A dash and A corresponding to the end A of the line AB. Similarly, corresponding to the end B of the line AB, so points B dash and B, they will be located alongside one vertical projector line over here. So we have to draw a distance of 60 millimeter from the end projector corresponding to the end A. So at a distance of 60 millimeter, we will be drawing a vertical projector line in such a way that this projector line will be containing the projections corresponding to the point B over there. That is the front view projection as well as the top view projection corresponding to the point B will be located onto this particular vertical projector line. Now we know that end B, it is lying 50 millimeter from the horizontal plane. Since this end B also lies in the first quadrant, so the distance of the point B above the horizontal plane is 50 millimeter. So this distance of 50 millimeter we are going to mark alongside this vertical projector line, and we will be able to obtain the location of the point B dash over here. So this is the location of the point B dash in the front view. Similarly, the end B information is available with us that it is lying at a distance of 45 millimeter from VP. That is, this distance happens to be 45 millimeter in front of the vertical plane. So in front of the vertical plane means that this distance will be plotted below the XY reference line. So this distance of 45 millimeter we have marked it below the XY reference line. So points B dash and B, they have been located over here. So now we can check the front view corresponding to the point A has been obtained. The front view corresponding to the end B of the line has been obtained. The top view corresponding to the ends A and B, they have also been obtained into the orthographic projections. So now we can connect A dash with B dash and A with B over here. So here A dash B dash, it provides us with the front view projections which are the apparent length projections of the line AB. Similarly, projections AB in the top view, they provide us with the apparent view projections of the line AB in the top view projections, and these projections they have been obtained in the horizontal plane. Similarly, A dash B dash front view projections, they have been obtained onto the vertical plane. Now having obtained the front view projections and the top view projections of the line, now we are going to proceed to evaluate the side view projections of this particular line AB. So now we know that whatever is the height of the point A dash above the ground, so at the same height the location of the side view point A double dash will be located. So this height happens to be 25 millimeter. So from A dash we are going to construct a horizontal projector line or the construction line and extend it into the profile plane so that point A double dash should be located at a height of 25 millimeter above the horizontal plane. Similarly, here we have got point A, that is the top view projection. So we know that this distance of 10 millimeter is 10 millimeter in front of the vertical plane. So this distance in the top view projection of 10 millimeter in front of the vertical plane now needs to be transferred onto the profile plane, and this will be done using the transfer line over here. So what we are going to do over here, from point A we are going to draw a horizontal projection line in such a way that it should be extended to meet this transfer line over here. So the moment this projector line drawn through the point A in the plan, which is going to indicate 10 millimeter in front of the vertical plane distance over here corresponding to the end A of the line. So this distance now needs to be transferred onto the profile plane. Now the moment I obtain this point, I will be drawing a vertical projector line through this point in such a way that I have to extend this vertical projector line up to the horizontal locus line which was drawn through the point A dash from the elevation. So wherever this vertical projector line, which is now indicating, you can check 10 millimeter distance from the vertical plane. So this is the distance of 10 millimeter from the vertical plane. Now this is projected in the profile plane. So same distance was available in the top view projection. So this top view projection distance of 10 millimeter in front of the vertical plane has been transferred to 10 millimeter distance with respect to the vertical plane in the profile plane over here. So this way, the intersection of these two projection lines will give us the location of the point A double dash in the profile plane. Now, having obtained the point A double dash, now we have to proceed to locate point B double dash in the profile plane. So as we have discussed earlier, the height at which B dash point is going to lie in the front view, at the same height we will find that point B double dash is going to lie in the profile plane. So this is our profile plane over here. So at the same height, that is 50 millimeter above the horizontal plane. So we have marked this locus line corresponding to the height of 50 millimeter above the horizontal plane into the profile plane. Now this point B, it is located at a distance of 45 millimeter in front of the vertical plane. That is, in the top view projections corresponding to the end B of the line AB, this distance of the end B, it is 45 millimeter in front of the vertical plane. That now this distance of the top view will be converted into the distance from the vertical plane in the profile plane over here. So how this will be done? Again, we are going to make use of this transfer line in order to transfer this distance of 45 millimeter in front of the vertical plane to 45 millimeter from the vertical plane over here. And what we are going to do from point B, once again, we will be drawing a horizontal projector line and extend it till it intersects with the transfer line. So wherever this horizontal projector drawn from point B of the plan, it intersects with the transfer line. Now we have obtained a point corresponding to point B onto the transfer line, and you can check this distance. This is also 45 millimeter, and this distance, it is also 45 millimeter. So this vertical distance into the top view projection has been translated into the horizontal distance, that is distance from the vertical plane, as 45 millimeter into the profile plane projection over here. So from this point, once again, we are going to extend a vertical projector in the upward direction and extend this projector till this vertical projector, it meets the horizontal projector corresponding to the height of the point B dash from the front view. So intersection of these two projectors will provide us with the location of the point B double dash. So once we obtain B double dash, we have already obtained A double dash point in the profile view projections, and once we join these two points over there into the profile plane over here, now we will be able to obtain the right hand side view projection of this line, which has been drawn on the left hand side of the front view projection. So here we can see that front view projections A dash B dash, they happen to be the apparent length projections. The top view projections AB corresponding to the line AB, they are also represented as the apparent length projections obtained onto the horizontal plane, and the side view projections, that is the right hand side view projection, which are obtained on the left hand side of the front view, they are also representing the apparent length projections of the line obtained onto the profile plane. So with this, we have completed the discussion regarding obtaining the orthographic projections of a line which happens to be an oblique line, and this line is existing in quadrant number 1. So this is all for today. So I hope that through this discussion you would have understood how do we obtain the orthographic projections of an oblique line when the line happens to lie in quadrant number 1. So we'll be continuing with further discussion regarding few more illustrative cases regarding the projections of the lines in the coming lectures. So thank you very much. Thanks a lot.